I don't have any slides, just 2 tabs in my browser. So I'm Emmanuel, a senior web consultant from France, so sorry for my accent. And tonight I'm here to speak about Elasticsearch. How many of you have already used Elasticsearch before? 10 people, okay. In the next 30 minutes, I want to show you what kind of query we can execute in 2026 to find some data in Elasticsearch. So for the people that doesn't know what Elasticsearch is an open source project we can use if we need to add a search engine in our web application. So for example, if you are an e-commerce website, the search bar in the e-commerce website behind this feature is Elasticsearch most of the time. We can use Elasticsearch for 2 main use cases, search, and the second one is observability. We can index into Elasticsearch everything related to metrics, logs, everything, if you want to have a big picture of your infrastructure and see when something goes wrong. So everything I will show you tonight, you can do it with a search use case or an observability use case. So this is only the things I have tonight, just a bunch of HTTP queries. I will try to explain very briefly everything, just to be sure that everything is okay for everyone. In Elasticsearch, everything is API. If you want to communicate with Elasticsearch, you have to send an HTTP request. And everything is JSON. So before the talk, I have indexed some data, some movies. I have around, sorry for the zoom, is it high enough for everyone? Yeah, finger crossed. So I have indexed around 100 movies. For each movies, I have titles, director, actors list, and so on and so on. And we will try to use this data set to make some queries. Before explaining what is coming new in Elasticsearch, I want to explain what was the only way to do queries in the last couple of years. So once I index this data, I can now search for specific text in my data sets. So for example, let's have a look and search for everything that contains the Brooks string in my data set. And as you can see here, I have only one document. And why I have this document? Because this movie has Albert Brooks as an actor. So this is a very simple queries. I will explain how it works, and I will explain why this kind of query can be the limitation of these queries. So this is very simple query. I'm looking for a string in my data set. I can do something more powerful. For sure, this is HTTP request, but if you are a JavaScript developer, Java developer, you have a SDK specific for your programming language. Second example, I want to search for every movie that contains a science fiction string and that has a rating higher than 8.5 and a year higher than 2010. As you can see here, we have a more complex query. We can combine query all together to go deeper in our search. So if I'm doing a search, again, I still have one document, Interstellar, for 2014, 8.7 as the rating and contains the science fiction string in the document. So this is a more complex queries, but when you are used to do this kind of queries, it's quite easy to implement. And the last things we used to do a lot is aggregation. Let me format my JSON. Aggregation is the way you can group your data by a predicate you will define in your query. So for example here, let's say I want to get all my documents. I want to group them by the country, and for each country I want to get the average rating for each movie. So when you are doing Elasticsearch, you need to love JSON because it's only that. And in the same HTTP query, here we have different buckets. We can see that we have 65 movies from the USA. The average rate is 8.3. We have 9 movies from France, and the average is 8.0. This is the basic API we have since a very long time in Elasticsearch. It was the only way to do search. How it works. In fact, when we index a document in Elasticsearch for the very first time, Elasticsearch will try to find the mapping of the document. What kind of data I have inside. I didn't configure anything. So, oops, sorry. For example, here, for my data set, Elasticsearch understood that actors is a text, duration is a long, rating is a float, and so on. And when we index text property, this text property will be processed by Elasticsearch in a specific way, in order to be able to do search queries after all. This process is what we call an analyzer processor. We will analyze the string, we will do some stuff at index time in order to be able to do search query after. The first things we have when we process this string is we will generate different tokens. In fact, the string will be splitted into multiple tokens, and these multiple tokens will be stored in a data structure that we named inverted index. In fact, an inverted index is just a dictionary. You have a list of order token. You have the identifier of the document that contains this token, and that's it. So for example, here, if I use this analyze debug endpoint just to show you what will be generated for the string Albert Brooks, I say, okay, please give me the tokens that will be generated if I send you this string, Albert Brooks, with the configuration I define for the actors property. If I execute this debug query, you can see that I have 2 tokens that has been generated. So next time I try to search for the Brooks string, change the term string by keyword, by token, sorry. When I execute this query, Elasticsearch will find in the dictionary, in the inverted index, do I have the Brooks token in my dictionary? If yes, give me the identifier of the documents and fetch me the document and return the response to the user. So as in the previous query, a Brooks token has been generated, you can see here. When I do the search query, my document will be returned. So right now, all the search query we can do is based on the content of my document. If we have some missing token at index time, we can do magic after all. We can do a search query with something else. If this something else is not in my dataset, I won't find anything. For example, if I'm looking for United States, I don't know if you already saw that, but I don't have United States, I have USA. So if I have the USA keyword in my dictionary, the term United States, I don't have this one. So I will get no documents. How can we solve this problem? Without the new API, what we can do is something quite tricky, is to modify how the string will be processed during the at index time. I say that when a string is indexed in Elasticsearch, there is an analyzer that is executed, so we can update this analyzer in order to generate more token. For example, here, it's a long JSON, but it's not all the JSON is important. I said, every time I will index a document, the country field is of type text, but I will analyze it in a different way than the default analyzer. And what I have in this country analyzer I create above is I will assign a synonym dictionary. This is something I have to configure on my own. It's not magic. I have to define, okay, every time you have the USA token, this is the synonym you can add in the token list. So United States, US, America, and so on. And thanks to that, the search query I was not able to do in the previous queries, I can do right now. So for example, if I create a new index, movies v2, I will take all my data from my previous index and move them to the new one. And if I'm using the same analyze endpoint, as you can see, for the United States string, multiple token has been created. USA, America, US, and so on. Because I configure my analyzer to do this kind of process. So the query that didn't work earlier, now work. I have 65 documents from USA. But doing this kind of stuff is quite boring to manage the dictionary of synonym and so on. It's quite it's very difficult to maintain, sorry. So with this AI world we live during the last couple of years, can we do something else? In one of the latest version of Elasticsearch, we can do semantic search. Earlier, our data was stored in an inverted index. With this new semantic search, our data will be stored in a vector. A vector is a data structure that is used a lot in the AI world. A just floating point in a big array, and we compare floating point together to try to find similar documents. And with Elasticsearch, we can do that. We can reuse AI model that is already existing in Elasticsearch, or I can reuse, I can create my own if I want. I can upload my own model based on what kind of data I have, if I need. So for example, here I say, okay, I will create a new inference model that I will use when I will index my data. I think I have already created this one. Yeah, it was already created. And now, I have to define a new property in my document. And as you can see, the type of this property is quite new. For the moment, we already saw text, long, date maybe. Here we have a new type of field named semantic text. And we define what kind of inference model I want to use for this property. Thanks to this new type of data, I will be able to do semantic search right now. I will show you. And as I have two different properties, I need something to copy the synopsis field into this synopsis semantic field. And I don't have this synopsis semantic field in my data. So I need something to copy automatically my data I have already indexed into this new property. For that, I have created something that is not the purpose of this presentation. It is an ingest pipeline. It's just an array of processor. Every time a document is indexed in Elasticsearch, it will be executed through these processors. So for example, here I say, every time a document is indexed in Elasticsearch, I will copy the synopsis property into a new one named synopsis semantic. So let's create this pipeline. Let's create my new index. And then let's reindex my data into this new index. As you can see here, I say take everything from my movies index and reindex everything to my new one and execute at the same time the ingest pipeline I've just created in front of you. I reindex everything. Yeah. And if we have a look here, oops, sorry. Not a lot of new stuff, but as you can see here, we have two properties. The synopsis property I already have earlier, and the new one, synopsis semantic, that is totally the same value, the same string, but internally it's not stored in the same way. The synopsis property is stored in inverted index, and the synopsis semantic is stored in a vector. And thanks to that, we can do semantics query. For example, here I say, oh, it's not the first one, I think, yeah, this one. I want to get all movies that is about cars. It's just an example. If I execute this query, the first one is something about a driver in Hollywood and so on. So I don't have the term cars in my property, I think. No. But it was about to find similarity between this string and the one I was looking for. This was not possible with the previous API I showed you before. So two more examples, movies about conflicts between rich and poor, social inequality and so on. The first movie is something from South Korea about discrimination, healthy park family and the Kim clan and so on. Poor family scheme to infiltrate a rich household. So it's quite relevant. Based on the query I just executed. Last example. Well, it's the same. Some movie about reality. Someone that discovered that their reality is an illusion. The first document, the most relevant document that is returned, sorry, is the Truman Show, where it talks about a salesman discover his whole life is actually a reality TV show. So it's quite relevant based on the query I have executed, even if I don't have these tokens in my value. He was about to find some similarity thanks to some mathematical operations and on the vectors. He was about to find the right documents. So we can do full text search with the previous API. We can do semantic search with this new one. Can we combine all of them? And of course, yes. We can do some hybrid search. But every time we return a document, there is a score that is generated. The score is just how relevant the document is based on the query I have executed. And how the score is calculated is different if we compare the one that is generated for full text search and the one that is generated for semantic search. How it's calculated is different. That's why we need some process to re-rank the score in order to make everything more accurate. So for example here, we have many algorithms for re-ranking our document. For example here, I use the default one, RRF, and I say, okay, I want to execute this full text search. I want all documents that contain the dreams or mind token in my documents, and I only want the one with a rating higher than 8. And at the same time, I want to do a semantic search. I want all movie about dreams and subconscious. And so I think I will have something accurate. I have in the synopsis, I have dream or mind. I think I have mind, yeah, I have mind. The rate is higher than 8. And the semantic query about subconscious dream, I don't have a lot of data, so sometimes my result is not good enough. But something about unstable veteran, we're talking about mind, and so on and so on. So It's not exactly the same, but we are close to the queries. So this is just vectors search. We are only in the Elasticsearch ecosystem. Are we able to communicate with other LLM providers like Anthropic, OpenAI, and so on, directly from Elasticsearch? Yes, we can do that thanks to some retrieval augmented generation. We are able to connect Elasticsearch with some external LLM provider, for example here with Gemini. I already created this inference model because I didn't want to show you my API key. But I think, let's have a look. Gemini, yeah, it's already created. And thanks to that, I can do this kind of query. And this query will ask this is a prompt that will be sent to Gemini. How many Christopher Nolan movies do I have in my database? And of course, Gemini is not about to answer my question because he doesn't know anything about my database. He say, I need to know how your database is structured and how I can access it. So he gives some answer, maybe below. Yeah, he gives some answer, but maybe not accurate based on the data I have in my database. So how can we add some context in this communication between Elasticsearch and Gemini? We have to do that with this kind of API in 2 steps. We have to do first the queries. So I'm looking for Christopher Nolan movies. And then when I calling Gemini, I need to pass all this context in the same prompt. So this is quite ugly to do. When you will develop something with Elasticsearch with your JavaScript or Java or so on, you will do it programmatically. But with this API, we have to put the context inside the prompt. So for example here, I give all the Christopher Nolan movie I have in my database, and at the end I ask a question, how many Christopher Nolan movies I have? This is totally useless because I can query Elasticsearch to know how many films from Nolan I have, but this is just for example. And of course I can ask more questions. For example here, at the same time I ask to give me the French version of the title. So I don't have this information in my database. If I execute this, sorry for the zoom, but yeah, Dunkerque. The French name is Dunkerque. It looks correct. And this again, this information I didn't have this information in my dataset. So we are now able to communicate with the LLM, ask them to generate something based on the content I have in Elasticsearch. And one of the latest way of doing queries, we have a new queries engine in Elasticsearch named ESQL. It's very new, but we can do the same kind of things I've just shown you in only one queries. For example, I will try to explain. I will do something like that. So this is a new way of writing query in Elasticsearch with a new syntax. It's looked like pipe command in Unix world. I want to look where in my movies semantic index. For what? For all movies where the director is Christopher Nolan. I want just the 10 first documents. And I will generate, based on the result, I will generate a prompt. This is a concatenation of multiple string. And then I will ask my LLM. I will send this prompt to Gemini, and I hope Gemini will answer my question. Sorry, it's below. Yep. I have the title, the year, and some information. I ask Gemini to summarize the movie in few lines. So it gives me a text that doesn't come from my dataset. So this is a way we can do this kind of communication between Elasticsearch and an LLM in only one HTTP query by using the new ESQL query language. Okay, now this is only available in Elasticsearch. With Elasticsearch, we have also a UI named Kibana. This is the UI I use for the demo. It would be fun if we can have something like an assistant directly in Kibana and be able to write to ask questions to this agent and try to get some information about the data I have. And Elasticsearch, via Kibana, we are about to chat with Anthropic Claude Sonnet 3.7, but you can change your LLM if you want. But we are about to use this agent to ask questions, and automatically this agent has some capabilities. It can list all the indices I have in my Elasticsearch. I can do search query. I can get document. I can do a lot of things. So, for example, if I list again, can you list all movies directed by Christopher Nolan? At the same time, I will show you what we can do. I will let him work a little bit, but you can create your own agent if you want. You can give more context about how the agent will answer to my question. You can give some details, and you can give some tools. For example, here, my agent can do search query, can get a document by ID, can execute ESQL query, and so on and so on. So you can give capabilities to these agents. So if we go back to my agent, I have my 8 movies directed by Christopher Nolan. I think I had 8. I don't remember. 1, 2, 3, 4, 5, 6, 7, 8, yeah. Automatically, the agent uses the data I have in Elasticsearch. And in fact, we can do this kind of stuff also in your most loved LLM chats window. So I use Claude. I have connected Claude to an MCP server from Elasticsearch. We can, if I have a look here, we can get we can get an MCP server directly from Elasticsearch. I connected this MCP server to Claude. Again, I won't show you the configuration because you will see all my tokens. But I can ask, can you list? I can copy paste maybe. Yeah. Can you list? And you will see the same kind of information. It was quick. No, it's not mine. Can you list? Yeah. Yeah, it doesn't know. Yeah. Here I have to define in my database because it doesn't know that I want to filter only the one I have stored in Elasticsearch. He lists the indices. Then he will get the mappings. Then it will do the search. If we have a look, we have some query I just showed you at the beginning of the presentation. So via Claude, we're able to interact with Elasticsearch, and here I have my 8 movies. Yeah, 8 movies that is written automatically thanks to the MCP server that is available in Elasticsearch. This is the end. I'm not an expert with LLM. I'm an expert in Elasticsearch, but I wanted to understand what is the new way of doing search with Elasticsearch. That's why I'm giving the talk tonight. This is the only new API I wanted to show you, but Elasticsearch moved a lot. Every new version of Elasticsearch has a lot of new features, so sometimes it's hard to follow. But if you want to play, I've created, I'm not working for Elasticsearch, so I don't get anything from them. But you can play with a 14 days account, 14 days free account on elastic.cloud. Something. We can create a serverless instance and start playing with Elasticsearch. Thank you, all of you. Do you have any question? Yeah.
Yeah.
You.
You didn't mention the pricing of Elasticsearch. I haven't used it. Can you say how much is it? Is it good for side projects or personal stuff? Or?
For personal project, is maybe too heavy, maybe. Because you have to host Elasticsearch on a server, you have to pay. It's not the cheapest SaaS solution in the market, so maybe it's more expensive for your small projects. For your small project, you have other search solutions available, but without maybe this kind of technology. I don't remember the name. There is a small SaaS product that gives the possibility to do search queries. Maile search, M-A-E-L-E search, I think. But for big company, big projects, most of the time they use Elasticsearch. I'm from Lille in north of France. Lille is known for e-commerce retail company. All the retail companies like Auchan, Decathlon, Leroy Merlin, and so on are from Lille, and they use Elasticsearch as a search engine.
Okay, thank you for the presentation. This is quite helpful because I'm with a team that very soon will start working on projects that will use Elasticsearch. So it's quite helpful. And just a question about at the point where you're indexing, right? So did you have like schema created for your data first before you index?
No.
When you're setting up?
No. When I index my first document in a new indices, Elasticsearch will create the mapping for me. So let me show you. What can I do? For example, I will delete movies v2. If I index here. So movies v2 does not exist. I have deleted everything. If I try to get the mapping of movies v2, I have an error, an exception, because they say that the index does not exist. Sorry. If I reindex everything to these new movies, v2 index, this mapping is created automatically by Elasticsearch. Elasticsearch is able to find for each field in my document of which type is it. Is it a text, a long, a date, or anything else? It's the wow effect. I'm not sure we can say that in English, but the wow effect, it works without configuring anything. But most of the time when you have an issue with Elasticsearch, a performance issue, a billing issue, a storage issue, most of the time is due to the mapping that is generated by default automatically by Elasticsearch. You have to optimize it in order to reduce potential issue later.
Okay, so by optimizing it means you have to create like custom mappers yourself.
You have to. I can speak about Elasticsearch during 3 days. When you have to modify the mapping, you have to think what kind of query I want to provide to my end user. Based on that, there is some mechanism in Elasticsearch you will enable in the mapping. You say, okay, I want to do this kind of query. Okay, in the mapping, I have to define this property, and configure everything correctly. But you have to ask first what kind of query I want to provide to my end user.
Nice. Thank you.
Yeah, there is one, just to explain that when something goes wrong with Elasticsearch, most of the time is the mapping. In Leroy Merlin, I used to work for them a long time ago, 7 years ago. They have a batch process that will synchronize all their product in a relational database into Elasticsearch. So they take everything from the PostgreSQL or something like that. They take everything and put everything in Elasticsearch. The batch process was about, I don't remember the exact value, but what around 3 or 4 hours to execute. Just by optimizing the mapping. I don't remember the exact number, but I think we divided by 4 the time needed for indexing everything.
So sorry, just to build on that is, when this data are being sent to Elasticsearch, probably to populate it, right? There is no structure whatsoever to it. And Elasticsearch just creates structures for it based on that. So, okay. Interesting. Thank you.
So you mentioned that there is no schema for the Elasticsearch indexes your data, but eventually, what's this default? Sorry.
The default depends on the first document you index.
No, but I guess a simpler question: is the default is it doing like an SQL style base tabular data storage or something else, or?
It's a document-based storage. It's like MongoDB. You store SQL. Then this is the original data that is stored like JSON object, like in MongoDB. Then every property in this document is Elasticsearch will try to find what kind of data this property is. Is it a string, a long, and so on. And then based on this type, it will store this information in another data structure that is named inverted index. And this mapping is already generated by Elasticsearch when we send to him the very first document in my index. So for example, if you send a document where a property is a string, but if we are not lucky, in fact, it's not a string, it's a date. The other document we send is not a string anymore, it's a date. Elasticsearch will fail because we can't store a date in a data structure where the first document was a string. It will fail during the index time. So that's why we have to define clearly what is the mapping of Elasticsearch. If you don't do that, you will have some issue later.
Right. Thanks.
Yeah.
Can I just get some more clarity around the semantic fields? You mentioned earlier that there is some LLM running in the background, so the semantic field will be a vector store essentially with that word mapped out as needed. Now, do you need to communicate with an LLM outside of Elastic?
No.
So this is already...
For semantic search, I was not communicate with
any LLM?
No, I was inside Elasticsearch. We have a bunch of model here, I think. Here. We have, I'm using Elastic Serverless. I have a bunch of already usable model based on what kind of data you have, what kind of query you want to do, and so on, what kind of billing you want at the end, because I think there is some model that is more expensive than other one. So you have dedicated model. You can use this model inside Elasticsearch, and when I'm doing semantic search queries, I'm stay inside Elasticsearch.
But you're still using an external model?
Yeah.
Like Anthropic, let's say.
You can do that. Here we have some model using Anthropic. You can do that, but if you want to use the model built by Elasticsearch, you can do that also.
Okay.
So you have the choice. You can talk with something else, but you can stay inside Elasticsearch if you want to. If you use the model that is developed by Elasticsearch.
Okay. And then, does the index need to be of any special kind, or can it just be any index and I just need to map a field as a semantic field and it will work out of the box?
You have just to define the semantic text type of field in your mapping. That's all.
Okay. Thank you.
There is a question with the guy next to you.
Yeah, sorry if I missed it earlier, but speaking of hybrid searches where some is, like just a text type search and so on, but you're using semantic search at the same time, is it automatic behavior kind of good enough, or is there a bit of an art to kind of tweaking the relative importance of one versus the other?
Yeah, you have to. I'm not expert with this part of re-ranking, but you have to benchmark the result, and based on that, you have by default, I think you have 4 or 5 algorithms to re-rank your data based on what kind of data you have and what kind of query you want to execute. And then you can also execute AI model to re-rank your result dynamically. So, but you have to test your queries in order to understand if the results are relevant or not.
Thank you.
But the answer is not instant magic.
Okay.
Yes.
So this is a question coming from a legacy system. Can you hear me okay?
Yeah.
Do you know when the semantic searches, the semantic fields started coming into Elasticsearch, and is there an equivalent when you use AWS OpenSearch, for example? Or
Good question. I think semantic search came after the fork,
okay.
after the OpenSearch / Elasticsearch war. I think it came after. So in OpenSearch, this semantic text field does not exist in the same way, but they maybe add this kind of behavior in their own side, maybe, I don't know. But this feature came after the fork.
Okay. Okay.
Thank you.
Great.